So you should have a note sheet that will follow along for today's lesson. This is section 7.1. We are dealing with operations on functions. When I say operations, I'm thinking add, subtract, multiply, and divide. Okay? Those are the 4 operations that we know. We are going to add our functions, we're going to subtract them, we're going to multiply them, and we're going to divide them. As well as do some other stuff with compositions. Here's 7-1. So let's start with the adding, subtracting, multiplying, dividing. So if we're adding 2 functions, I just want to talk about notation to start. For adding 2 functions, what is that going to look like? Well, it's going to have this right here, the f plus g of x. You guys have this table on your notes handout, right? Okay. Adding 2 functions, we know we're adding because clearly there's a plus sign there. So we're going to take our f function, whatever it is, f of x, and add it to our g function, g of x. And we'll just add like terms. It's basically like adding polynomials like we did in the last chapter. If we're subtracting, there's obviously going to be a minus sign here. So we'll take f of x and we'll subtract from it g of x. So just like in chapter 6 when we subtracted polynomials, we had to distribute a -1, right? And then we just added like terms. We're going to do the same thing here. Multiplying polynomials, there will be a multiplication symbol to tell us to multiply. Take f of x times g of x. Back in chapter 6 we took a polynomial times a polynomial, didn't we? Okay. Our functions are probably going to be polynomial expressions. And last we'll do division. We'll say f divided by g of x. We'll take our f function, we'll divide it by our g function. Now this one has a little bit of extra stuff. We've got to think about domain. We haven't talked a whole lot about domain recently, but we will. When we are dividing, you've probably heard me say you can't have 0 in the denominator of your fraction. That much thought. We say, oh, we just can't have 0 down there. We're going to have to figure out what value of x is going to make our denominator equal 0, and we're going to have to exclude that from our function, okay, from our domain. We'll talk about that when we get to some division problems. So let's start by looking at the first example. It says given f of x equals 3x squared plus 7x, and g of x equals 2x squared minus x minus 1. Find f plus g of x. So what operation are we doing to our 2 functions? Addition. There's a plus sign. So we know we're adding. So let's take our f function and we're going to add it to our g function. Our f function is right here. So we're going to take 3x squared plus 7x. And we're going to add to that our g function. This should look very familiar from what we did in the last chapter, does it? We're adding our 2 polynomials, so let's just add our like terms. So term by term to see if you have any like terms. I do have other x squareds, so 3x squared plus 2x squared is 5x squared. 7x and negative x. What is 7x minus 1? A plus a negative 1. 6x. And last we have minus 1. 5x squared plus 6x minus 1. We've added the 2 functions. There's nothing else to do. We're just adding the 2 functions here. This next example, we're using the same 2 functions. This time we're subtracting. We're subtracting the 2. So let's start with our f function. And from that, we're going to take away the g function. It's f minus g. I have it in that order. This is the one where we're going to have to distribute a negative, or another way I tend to think of this is make that a plus sign, and then what am I going to do with every sign? Change it. So now add your like term, just like we did in the last example. 3x squared plus negative 2x squared is 1x squared, or just x squared. 7x plus x is 8x, and then plus 1. This is the difference of those two functions, 8x squared plus 8x plus 1. I want you guys to try the next one on your own, where you are going to be adding the two functions. Okay, if we're adding these two functions, we're going to take f, 2x squared plus 5x plus 2. We're going to add to it the g, 3x squared plus 3x minus 4. We have like terms. What is 2x squared plus 3x squared? 5x squared. We have our linear terms. 5x plus 3x is 8x. And 2 minus 4 is 2. How many of you got that correct answer? Good job. Looks like our right answer should be letter A. This next one is a subtraction problem. Should we go ahead and try that one, please? Okay, if we're taking the f function, 2x squared plus 5x plus 2. We're subtracting from that 3x squared plus 3x minus 4. Did you guys remember to change your signs in the second polynomial? Got a plus and then change all of my signs. So now add your like terms. 2x squared plus a negative 3x squared is negative 1x squared. 5x plus a negative 3x is 2x. And then 2 plus 4 is 6. How many of you got that answer? Good job. Okay, so are there any questions on adding or subtracting functions? So let's look at multiplication next. So it says given f of x equals 3x squared minus 2x plus 1 and g of x equals x minus 4, find f times g of x. So we're taking f of x and multiplying it by g of x. So here's our f of x function, 3x squared minus 2x plus 1. We're taking that times our g of x function, which is x minus 4. I know we're multiplying because it said multiplication clearly in the directions. So let's distribute and combine like terms. Starting with 3x squared. 3x squared times x is 3x to the third power. 3x squared times negative 4 is negative 12x squared. Let's go to negative 2x next. Negative 2x times x, negative 2x squared. Negative 2x times negative 4, positive 8x. Distribute the 1 next. 1 times x is 1x, or x. 1 times negative 4 is negative 4. Okay, so we distribute all the way through our polynomial. Now add like terms. Is there anything I can combine with 3x cubed? Any other x cubes? No, so we'll bring down 3x cubed. We do have a couple of x squareds there. Negative 12 and negative 2 add to negative 14. Be careful, they're both negatives. Just add them. Negative 12 plus negative 2. Add our linear terms next. 8x plus x. 9x. Remember, there's a 1 in front of that x. Minus 4. 3x cubed minus 14x squared plus 9x minus 4. So that one we're multiplying our two functions. Let's look at a division problem. This time we're given the same two functions, so that hasn't changed. We're dividing. Let's go ahead and write what it's going to look like. Let's take f and divide it by g. I'm taking my f function right here. 3x squared minus 2x plus 1. And let's divide that by our g function. The g function is x minus 4. Would you like to do polynomial long division or synthetic division to get this answer? You could. I'm not going to require that you do that. You can leave your answer like this. However, I do want you to tell me what... I can't have 0 in the denominator, correct? We talked about that earlier. What value of x, what number could I put in for x that would make my denominator equal to 0? 4. If I was to put 4, what if I put 4 in for x? Well, 4 minus 4 is going to give me 0, isn't it? I can't have that. I can't have 4 in the denominator. So we need to make sure that we state that x could be anything except 4. So we're just going to say, let's put a little comma or semicolon there, and I'm going to say x cannot equal 4. You have to give that exception. Okay, when you're doing these dividing the functions. You have to state what x could not be. And that's it for division. So this is what I get when I have f of x divided by g of x. In addition, I need to state what value of x is going to make my denominator equal to 0, which in our case is 4. So let's start with f of x. Here we're taking f of x times g of x. So my f of x function, I have 2x squared plus 3x minus 1. Taking that times the g of x function, which is here, x plus 2. We need to distribute. Starting with 2x squared. 2x squared times x would be 2x cubed. 2x squared times 2 is 4x squared. 3x times x is 3x squared. 3x times 2 is 6x. Last will be negative 1 times x and negative 1 times 2. We do have like terms that we can combine. No other x cubed, so we'll bring that down. We have x squared there, so we have 7x squared. We have linear terms, so plus 5x minus 2. Letter C? Letter C is the correct answer. Let's look at one more. This next one is division. I want you guys to try it, and then we'll compare answers. Okay, so we take our f function, we have 2x squared plus 3x minus 1, and we're dividing that by g of x, which is x plus 2. What can x not equal? Negative 2. If x is equal to negative 2, our denominator would be 0. It's okay to have 0 in the numerator, right? You can calculate 0 over something. You just can't have something over 0. So I agree. X cannot be negative 2. Alright, so are there any questions on adding, subtracting, multiplying, or dividing functions? See what I mean by it's not all hard stuff, just a little bit time consuming. So let's move on, because I think we can definitely do more. So on the back side, we are going to be talking about composition of functions. We've sort of kind of done this, but we haven't called it composition of functions. Okay, we have evaluated functions. We put numeric values into a function. We put a monomial into a function. We put a binomial into a function. We just haven't put a function into a function yet. So this model here is talking about composition of functions. It says suppose f and g are functions such that the range of g is a subset of the domain of f. And the composition function f composite g can be described by f composite g, which is equal to f of g of x. Okay. So let's talk about what this means. F composite g. First of all, that's not fog. Okay, so don't call it fog. If we read that as f composite g. F composite g. That's fancy for saying, let's put the g function in for the f function. Okay. We read it backwards as far as the process. We're going to take our g function and we're going to put it into the f function. So on your note paper, on the top it has, on the back side, it has composition of function, and it has f composite g of x. Okay? So let me write the notation just like it's on your paper so there's no confusion. And we're taking the g function and we're putting it into the f function. That's what that means. So how are we going to write that? We're going to write f. We're putting into f. What are we putting into f? G of x. Okay. We're going to put that g function, we're going to put it into our f function. So f composite g. We could also go the other way. It looks like goth there. Not goth. It's g composite f. That circle means composite. This time we're going to work the other way. We're going to put f of x into g of x. So this time we're taking our f function and we're putting it in to the g function. So what is that going to look like? Well, we're going to have our g function, and into that g function we're going to put f of x. When we do compositions, we read them backwards. We read right to left. So f composite g, again, means we're going to take the g function and we're going to put it into the f function. G composite f, we're going to start with the f function and we're going to put that into the g. This is the first example you guys have on the backside, right? Example A. Okay, so we have two functions. First of all, do you see the two functions? One is an f function, right here. And we have a g function, right here. We don't usually see functions as ordered pairs, but that's how they're set up for this first example. F of x is a set of ordered pairs, and g of x is a set of ordered pairs, right? In an ordered pair, do you everybody agree that we have an x and we have a y value? X, what do we call that x? It's our domain, but also our input. What do we call the y coordinate? Output. The x is your input, the y is our output. Okay. So they're asking us to find two things here. They want us to find f composite g and g composite f. It says to find f composite g, evaluate g of x first, and then use the range, or the output, of g as the domain of f and evaluate f of x. Okay, that's way wordier than it needs to be. So f composite g, let's start there. Okay, in f composite g, which function do we start with? G. So basically we're taking our f function and we're putting in its place g, right? So start with your g function. It's this right here. If I put 7, what do I get out? Put in 7, what do I get out? 0. See that? 7's my input, 0 would be my output, right? So if I put 7 into the g function, I get out 0. Right? You okay with that? So let's put 0 in for x in the f function. Okay? We're putting 0 in for x in the f function. Is there a spot where I can put 0 in? Yes, right here. So when I put 0 in, what do I get out? -1. So look right here. I've got it written out. f of g of 7. So again, I put in 7, right? Put in 7, and I got out 0. So then I'm going to put 0 into the f function. Well, I put it in for x. X is my input. Put in 0, and I got out -1. So we're going to say our answer here. We're going to say it is 7, -1. Where did this 7 come from? It was the first number I put in, wasn't it? I put 7 into G, put 7 into G first, and I got out 0. Then I put 0 in and I got out -1. So where did -1 come in? It was the last output, right? So 7 was my first input and -1 my last output. Let's try the next one. F of g of -1. So start with your g function. Let's put -1 in for x. What do I get out in that g function when I put -1 in? 7. So now we need to put 7 into the f function. Can I put 7 in for x? Yes, I can, right here. When I put 7 in, what number do I get out?
7.
I also get out 7. So my ordered pair, first input, last output, what's my first input? -1 and my last output? 7. So let's do f of g of 4. What are we going to put in first? 4. So I put 4 in, what do I get out? 9. So then let's put 9 into the f function. When I put 9 in for f, what do I get out? 4. So I got out 4. So my ordered pair is 4, 4. First input, last output. F of g of 8. So if I put 8 into the g function, here, what do I get out? 2. So let's put 2 into f. What do we get out? 6. So my ordered pair is 8, 6. I put in 8 first, and I got out 2. So then I put 2 into f, and I got out 6. So each of these ordered pairs would represent f composite g. Wasn't so bad, was it? Okay, so let's do G composite F. We're going to use this same function as a second ago. Some functions. Okay, so I'm going to use this slide again. We're doing G composite F. So this time, which function are we going to start with? The F function. I'm just going to go ordered pair by ordered pair. Let's start with 2. I'm going to put 2 in first. What am I going to get out when I put 2 in? 6. We get out 6. So it's going to be 2 comma something, right? So let's put 6 into the G function. Can I put 6 in for X? I can't, can I? There's not an X coordinate in the G function. Alright. So we're going to say that that first G composite F, that first is undefined, is what we're going to say. It didn't work out, so I'm just going to write it as undefined for each one that does not work. Let's go to the next ordered pair. Starting with the F function, I'm going to put in 9. Put in 9, I get out 4. Can I put 4 into the G function? Yes. When I put 4 in, what do I get out? 9. So what's my ordered pair? 9. 9. First input and last output. The next ordered pair is 7, 7. So let's put 7 in. When I put 7 in, I get out 7. Can I put 7 in for X in the second function? Yes. I put 7 in, I get out 0. So what's my ordered pair? 7, 0.
Is this all?
Huh?
Is this just it? This all it is?
It looks worse than it is, doesn't it? I put 0 in, what do I get out? -1. So put -1 into G, what do you get out? 7. So we have 0, 7. Make sure you look at your first input. 0, get out 7. So we got 7. Any questions on composition of functions with ordered pairs? That should have taken up, no, that wasn't that. I'm going to skip example B for right now. I think we'll probably have to revisit that on Wednesday when I see you guys again. Let's go to example C. So they're asking us to do two things here. The first thing they want us to do is find F composite G, and then we'll find G composite F. They're giving us two functions, f of x, which is 2x minus 5, and g of x, which is 4x. Okay, so let's start with f composite g. When we're working f composite g, which function do we start with? G. We work right to left, so we're going to start with G. This means we're going to take G and we're going to put it into F, right? So this is G right here, 4x. I'm going to put it into F of x. Okay, I'm putting it in for x. We've done this, haven't we? We've put a monomial in to a function before. We're going to put 4x into this function. You guys with me? No? It's a different problem you have on your notes, isn't it? Okay, is that what's throwing you off? Okay. Cross off those, well, just go down below. There's room down below. Do this down below with me. It's okay, because we'll go back and pick up those other two. I'm going to start off with a simple one. So just on your note sheet, Danny, down below. Sorry for the confusion. Okay, so everybody okay with putting 4x in for x? So what is that going to look like? Well, we're putting 2 and in place of our x in f, I'm putting 4x. Can you simplify that? Yeah, what's 2 times 4x? 8x. Can I take 8 minus 5? That's all I can do, is just 8x minus 5. Okay, so look at G composite F. This time we're going to take our F function and we're going to put it in to G. So where's our F function? Our F function is right here, 2x minus 5. And we're going to put that binomial into the G function for x. So this time I'm taking out the x and 4x. And I'm putting it in its place. 2x minus 5. Is this something you can simplify? Yes. Yeah. 4 times 2x is 8x, and 4 times negative 5? That's a good point. They're not like terms, so obviously we can't go any further. These okay? Any questions? Alright, I want to do one more example with you guys. This is your example C, isn't it? Okay. Let's see how far we get. Maybe I'll just do one of these. I don't know if we're going to get F composite G and G composite F done. Let's start with F composite G here. F composite G. Okay. So F composite G means we're taking our G function and we're putting it into the F function. So here's G. And we're putting it into the F function. Now, I've got 2 x's here. I've got to put it in for both of those x's. So I'm putting a binomial into the f function. I'm putting my g function into the f function. So let's write out what that's going to look like. 2x minus 1 minus plus 4. Thank you. Yes, it should be squared right here. So that brings up another point. We have a binomial squared. How do we simplify a binomial squared? 4. So right here, we're going to do 2x minus 1 times 2x minus 1. Which should give me 4x squared minus 2x plus 1. 4x squared minus 4x plus 1. Kind of box this in a little bit. Is that just kind of a side note there? So when I fill out, I got 4x squared minus 4x plus 1. Now what am I going to do with that answer? Multiply by 3, yep. Isn't there minus times 3 here? So I'm going to go ahead and do that. So 3 times 4x squared is 12x squared. 3 times negative 4x, negative 12x. And 3 times 1 is 3. Keep going. We've got a negative 1 here, so we're going to distribute a negative 1. Just want to make that a plus and change your signs. So negative 2x plus 1. And then I have plus 4. So let's clean this up. Combine like terms. That's 12x squared. No like terms to add to that. I have negative 12x and negative 2x, which add to negative 14x. We have 3 plus 1, which is 4, and 4 plus 4 is 8. 12x squared minus 14x plus 8. That was F composite G. We would still need to do G composite F, but I think I'm going to save that for when I see you guys again. And we're going to never review it. We've covered a lot of stuff today. I don't think it's necessarily hard stuff. It's just challenging your brain just a little bit. So your assignment is not going to be due until Thursday. However, I'm going to go ahead and give it to you because I know a lot of you will want to work on that later.
Oh, we get it finished, and then Wednesday comes around, what do we do on this? And what if we have writings? I probably won't have them.